afternoon, freaks, and now we are going to understand about the ideas of the basic fundamental concept of the physics that is called as the system and the measurement. So system and measurement means in this chapter you try to see the world through the idea of the measurement, because the pillar of the physics rests on physics. The idea of the physics itself, like when you are looking at the laws of nature and then you are trying to understand the things around us, the physical world around us, then you find that they have certain peculiarities or the properties. And to understand the nature, the behavior of those properties is called studying of laws of nature or studying of physics more importantly. We can also use the power of imaginations in different situations, and along with that we'll be discussing the various theories propagated and theories propagated by various scientists. But before going into those theories, I would like you to see the nature itself with an open mind now, and try to understand that the laws of physics or the physics itself largely depends on the four pillars, and these pillars are called the foundations of the physics. The first point is observation. Observation. Second point is called hypothesis. Third point is called experimentation. And fourth pillar is called as theory. So observation means when you observe something, like for example, I give you one simple example, that when the Newton observed that the apple fell on the ground. So he observed and the questions came to his head that why apples are falling on the ground, why they are not flying away from the ground. The very idea was that what was the reason, and that was the question flashed to his mind, and then later he developed very theories. But before those theories, first he tried to understand the hypothesis. So what the idea says that he saw falling of an apple is called observation. So observation, falling of an apple. And then the hypothesis is called inferential knowledge. Like we are all gurus in the world. If you ask any question to anybody, then they always have certain answers. That is really different whether the answer is correct or not. But everybody have the answer. So the hypothesis actually thrives on those inferential knowledge where the people just see something and they say that that might be just a speculative idea, no experimentation, nothing. It comes to their mind, maybe through the experience, maybe through the stories told to them by their ancestors, and that guides them to have the hypothesis. So in this experiment we can have the hypothesis that Earth attracts the apple. Then the experimentation. Experimentation means allowing the same experiment, same process, same phenomena. Let the apple fall from the tree, throw the stones and let how it's falling. So these are the certain things called the experiments. Now you're repeating the same incident again and again, and that is called the experimentation. This also involves measurement. You are measuring certain physical quantities, physical natures like the length, mass, time, etc. And that everything is the part of this experimentation. And then with the experimentation you are collecting the data, and with that data you are framing out, plotting the graph, maybe with the help of those graphs to try to understand the relation between different physical quantities or different characteristics. And the next is theory. Theory is something very concrete, very close to the truth itself, and that is based on those experimentation, the theory. So the Newton's law, that is a theory. Einstein's law of relativity, that is a theory. However, the difference between the Newton's law and the Einstein's special theory of relativity is that Einstein's special theory of relativity originated by the thought processes. However, the Newton's theory came after a rigorous set of experiments. So the Newton did the experimentation first, then he got the idea of a theory. However, the Einstein, he had a thought process, just imagine the different situation and try to understand that why, what would be the change in the processes or the behavior of the quantities under those different situations, and that idea is done by the Einstein. And you can say the Einstein's theory were mostly hypotheses, and later means after his death, still the experiments are being performed that whether the Einstein was correct or not, and the most of the time, most of the experiments suggest that he was absolutely correct. Maybe some little differences, but it says that Einstein's special theory is just thriving on all the tests, methods, all the methods that are trying to test its authenticity and the correctness of the experiment, but still find that Einstein theory is supposed to be correct. Now the theory. So now here in this chapter we will be dealing with the experimentation, and with this experimentation now we are going to understand called system and measurement. So system and measurement. So MEASUREN, system and measurements. Now if you see the things around us, the physical world, we perceive the physical world with the help of our eyes, our sense organs, all the 5 sense organs what we have. With the help of those sense organs we perceive the physical world, and we have designed certain quantities. They are called the fundamental quantities. Like the first fundamental quantity is distance. Let me clear this mess and then I'll write. So to measure the physical world we need to have some fundamental units. Fundamental units. What is unit? Like we have fundamental unit called length. Length is just the distance between 2 points, like the point 1, point B. This thing, the separation between these two is called as length. Thickness, height, depth, all these are the part of the length only. And the length is measured in meter. Now what is meter? Meter is defined as the time taken by speed of light, time taken by light to cover a distance into roughly 1/3 into 10 to the power 8, because the idea is that speed of light is 3 into 10 to the power 8 meter per second. It means to cover distance of 1 meter, the time is 1/3 into 10 to the power 8 second. So in this time, in this 1/, it's not exactly, just something like 299, something like that, but I don't believe in 299 because we will be using the idea of 3 to 10 to the power. We don't have to write what is the standard unit of this distance, but it is not exact value, it is approximated value. So 1 meter is the distance traveled by 1/3 into 10 to the power 8 second. In that duration, whatever distance is traveled by light, that is called as 1 meter. Same way, you have number 2, the second unit called as mass. Mass is expressed in kg. There is a science museum near France, somewhere in Europe, and there is a stone of particular shape or cylinder is lying there, and there is the mass of 1 kg. So again, this is a standardized value, and this value is adopted as 1 kg. Same way for time. For time we have, these days we use the nuclear or the atomic clocks, and that is the 2 hyperfine levels differences between the radiations from the cesium-133. That definition is also not required, but we know what is time measured in that is called 1 second. Then we have the next quantity, number 4, is called electric current. Electric current, and that is measured in ampere. Again, this is another assumed value, or it is a standardized value. Then we have temperature. This is the physical quantity, temperature, and that is measured in Kelvin. Then we have called the luminous intensity. Luminous intensity, and that is measured in candela. Then we have the number of particles. Seventh one is called the number of particles, or the quantities, or the entities called as moles. So these 7 fundamental units, they design a system called SI, International System of International Measurement, System the Internationale, or you can say the international system. So in this system we have, these are the physical quantities: length, mass, time, electric current, temperature, luminous intensity, and the number of particles. It has been observed that if you see the physical world outside, they can be measured with these values, and these are called the fundamental quantities, and these are adopted value, or you can say standardized value, and you can't make any changes in them unless you change the basic definition. So the distance between the two cities is measured in terms of meters, or you can say more precisely, they have other units called, many like 1000 meters called kilometers, 1000 kg is called 1 metric ton, and so many seconds make an hour, 3600 seconds make an hour, and then the 12 hours make a day, like that, blah blah blah, things keep on happening. And now we have the derived quantities. So derived quantities you have studied in the standard 10 also, they are called as derived quantities, and these are those physical quantities which are derived out of the fundamental quantities, like speed. So what is speed? Speed is distance over time. What is force? So force is mass into acceleration. What is work? Work is force and displacement. So these are called the derived quantities, the quantities which are derived out of this. Now we are going to understand the dimensional equations of these quantities. So let me clear this mess. So now we have to find the dimensional equation. Dimensional equation. How to find the dimensional equation, and what are the dimensional equations? So dimensional equations are the equations which are represented in terms of the symbol used for fundamental quantities, like distance is used as L, mass is used as T, capital M, time is used as T, ampere is used as A. So ampere is used as A. Temperature, that is Kelvin, is used as K. So when we have to find, suppose if I have to find the dimensional equation of speed, so speed is defined as distance upon time, right? So speed is defined as distance upon time, and the symbol used for distance is L. So this is L, and for time it is T. So it is L over T. So you can write L T to the power minus 1. So dimensional equation, this represents, if you just look at the dimensional equation, the symbol, So looking at this symbol, you can say this physical quantity is made up of the length and time. So I can, here you can say, it's suggested that you just write like this. So we are taking these 3 as the prime out of these 7, and then most of the physical quantities are made up of this. So if you see the dimensional equation of the speed, then just by looking at this equation you can see that this equation, this speed, has no mass. Means you cannot express the speed in terms of kilogram because it doesn't have the mass. So m0, and the L is occurring one time, and the time is occurring as the first reciprocal, you can say the multiple inverse of t. So it is just like, if you just write the unit of this, then you can write L as meter and second to the power minus 1, that is meter per second. So speed is expressed as this. Now suppose if I go for acceleration. So acceleration, you know the rate of change of velocity. Velocity is speed in terms that the object is moving in the same direction without changing its direction with the uniform, you can say in the same direction. Like if an object is going in a straight line without changing the direction, then the speed and velocity both are same. However, speed is just the rate of change of distance. So speed is only telling you the information that how fast an object is moving. However, the velocity is telling you that in which particular direction the object is displacing. So you know that you have studied all this in class 10, that the speed is a scalar quantity and the velocity is a vector quantity. There are certain situations where the speed and velocity both are same thing. Situation number 1, when the object is moving in one direction in a straight line, in one direction in a straight line, then speed and velocity can be same, because in that condition distance and displacement will also be same. Now if the object changes, like suppose if the object goes in this direction from here to here, then A, B, if you go from A to B along this curved path, that is called as distance. But if you see at each and every point the direction is along the tangent drawn at the specific point on the curve, so the direction is changing at all the points, but the distance is the total path length. Means the total length of this arc is called the distance, and the displacement is the minimum distance between the starting and the final position, that is AB. So that's why this is from A to B. So if you take this displacement upon time, you have the velocity. If you take the distance, now when this is a curved path, then speed and velocity both are different. But if you have this only one path, if your object is moving from point A to point B in this specific direction, then it is the distance and the displacement both are same thing, so you get the speed also as same. So I am trying to say that acceleration by definition is rate of change of velocity, but I can take the change of velocity, like a velocity minus velocity will be a velocity. So the difference of the two velocities will also be velocities, but the unit will be same as the speed. So I write here m0 L t to the power minus 1. This is the dimension for speed, because acceleration is speed upon time. So the dimensional equation is the dimension of speed over dimension of time. So dimension of time is capital T. Now I use the ideas of the indices you have studied in the mathematics. So it goes m0 L t to the power minus 2. So this is the dimensional equation of acceleration. Now if you try to understand dimensional equation of the force, then what is force? Force, by the Newton's second law of motion, force is mass into acceleration. So mass into acceleration. Now what is the unidimensional equation of mass? That is m. And what is the dimensional equation of acceleration? That is m0 L t to the power minus 2. So if you multiply these two, so you get m1 L t to the power minus 2. This is seen, everybody? Clear this line? So okay, so this is the dimensional equation of. So this is how we find the dimensional equation of different quantities. Now, after clearing this mess, we'll be discussing what are the uses of the dimensional. So the first use of the dimensional equation to check the authenticity of the equation. So authenticity of an equation. So we have some equations, very popular equations. We'll be using one of them, like v equal to u plus at. Now I want to check whether this particular equation is correct or wrong. So here you find that what is v? What does v signify? So v is speed or velocity. V is actually velocity. I just say v is velocity. This is also velocity. So the sum of the velocity and the velocity. So a into t is acceleration into time. So this quantity should also be velocity, because velocity plus velocity can only be velocity. It is just like if you have the mass of a body then broken into two or more parts. So the mass can be only equal to mass. It cannot be equal to mass, cannot be equal directly to something else like energy. Because if you say mass is equal to energy, it means you are trying to say that kilogram is equal to joules. So we are not using that idea, Einstein's E equal to mc square. We are just trying to say that. So now if you see the E equal to mc square, there is also no problem with that. So what is E? Energy. What is this? Mass. And what is this? C square. So mass into square of velocity can give you joule, but the mass cannot be joule. So here the velocity equal to velocity plus velocity. Now the question is that the velocity, we know that dimensional equation of velocity is L t to the power minus 1. So we write m L t to the power minus 1 and m is 0. This is also m 0 L t to the power minus 1 plus, is this also this same thing? So first we go for the dimensional equation of acceleration, which is L t to the power minus 2 and time is t, and suppose here I write m0 also. So now you check, this is also the same thing. So m0 L t to the power minus 1. So this is also same thing. It means this equation is correct, right? So this is how we check. Same way, if I just try to elaborate the another equation, S is ut plus half at square. So what is S? Displacement. Displacement. So the dimensional equation of displacement is m0 L t to the power 0. Like it doesn't have mass, it doesn't have time, it has only this. Some authors prefer writing L, M and T. It doesn't make any difference. They are same thing. Now same way, if you see the term ut, so what is u? Dimensional equation of u is m0 L t to the power minus 1 multiplied with t. So if you multiply, what you get? m0 L t to the power 0. So that is also same displacement. Same way, the acceleration time square should also represent displacement. What is acceleration? L t to the power minus 2 with definitely m0, and the t square, time square is t square. So it is m L t to the power 0. M is also 0. So that is also this. This is how you can find the application of the dimensional equation. This is called authenticity of an equation. Now second use of the dimensional equation is to check whether a given relation is really correct or wrong. So after clearing this mess, or maybe in the next video we'll discuss the other two parts. Thank you very much. Just subscribe to our channel and keep working hard.